All right, AP Chem. Apparently, when I film sideways, when I film with the horizontal, it didn't translate nicely to to YouTube. I don't know if I'm going to refilm that last video or I'll just let you watch it sideways. I'm sure you can figure out how to rotate your screen. At any rate, hopefully this video comes out better. And off we go. So you guys are asked to do question 112. The mass percentage of chloride ion in a 25 milliliter sample was determined by titrating with silver nitrate, which precipitated silver chloride. You got 42.58 milliliters of the 0.2997 molar silver nitrate, took equivalence point, and was the mass percentage of chloride ion in seawater if its density is 1.025 grams per milliliter. All right, 4 sig figs. Look at that, 4 sig figs in every number. So cool. On that note, here's how we solve this problem. So we can see the net ionic equation is simply that silver plus chloride goes to silver chloride. And when we have a titration, you can get the molarity by taking the molarity of one times its volume divided by the number of moles that you used. And that's equal to molarity of the second times volume of second divided the moles that you used. In each case here, the moles was 1, so n is 1 for all of these. So we end up getting an equation that looks like this, where we have the molarity of the silver nitrate times the volume of the silver nitrate equals x times the volume of seawater. And when we solve for x, we find that it was 0.51 molar. And I got a little lazy on my sig figs here. There are 2 more sig figs. I didn't bother writing them, but I did store them on my calculator. All right, so we've now determined that it's 0.51 molar in chloride. However, it asks for the mass percentage. So we need to figure out how many grams of chloride there is. So we're going to use that using our molarity t-tables. And so the first molarity t-table, we're just going to note that there's what it looks like. So the 0.51 molar we just calculated, 0.025 liters is what we're given. When I multiply those, I get the 0.1276 moles of chloride ion. But again, that's not what we need. We need grams of chloride ion. So coming on over here, there is our molar mass t-table. So 35.45 grams per mole comes from the table. 0.01276 comes from the other table that we just solved. Multiply those together to find that there are 0.4524 grams of chloride ion. Still not quite done. It asks for what was the mass percentage. So to get the mass percentage, we need to take the mass of chloride ion and divide by the total mass. But we've been told specifically that we aren't going to use 1 for the density. The density of seawater is 1.025 grams. So a quick conversion shows us that if we take 1.025 grams per milliliter and multiply it by 25 milliliters, we have 25.625 grams of water. And so the final is to take the percentage by the chlorine that we have and divide by the water that is the total, multiply by 100, and you get 1.765% chloride in seawater by mass.